Hey, good evening. Feels like it's been a while since I've done one of these videos, but I know I did one last week. But I'm going to go back over a few things on vectors that I gave you notes on in class today, because to be honest with you, I just didn't feel real comfortable about how I gave it to you, because I just felt kind of rushed, and I just want to make sure that we've got this down, because this is really not that hard. And so just want to make sure you got this. So vector we already talked about is a directed line segment with direction and magnitude. Remember we watched the little Despicable Me video with the villain Vector. All right, piranha gun. All right, the component form, I did talk about that. The component form is simply this. It looks just like a point, except it has pointed parentheses. That's how you know it's a vector. The first number is the x component, which is the same thing it is with a point, and the second number is the y component. So here if you have vector v, v1, v2 would be the component form. So if you're given 2 points, let's just say x1, y1, and x2, y2, then to find the component form, all you do is you take the end point, the second point, the terminal point, and you subtract the initial point. So we take x2 minus x1 and y2 minus y1, and we have our component form. Okay, and then the magnitude, which we talked about, is just the distance formula. I didn't give you this in class today, but the notation for magnitude is this right here. It looks like absolute value, except it's double bars. But here's the distance formula. And so basically, if you have the component form, you've already done a little bit of the magnitude, because it's sort of the same thing there. So let me show you a couple examples so you can do the worksheet tonight. And again, it's not that hard. All you're doing is finding component form and magnitude. All right, so example 1 here. Find the component form and the magnitude. All right, so in this example, we are actually given the diagram of a vector. It's not in standard position, but it's just a vector here. It starts at -1, 4, and it ends at 1, 1. Now, how do I know that it ends at 1, 1? Well, if you look at the arrow, it will tell you the terminal point. So wherever the arrow is, that is always the terminal point. So if I want to find the component form here, I'm simply going to take x2, which is the 1 here, and subtract x1. So I'm going to have 1 minus a -1, and then I'm going to take y2. Don't know why I wrote that in there. All right, sorry about that. Let me wipe that out there. All right, that's okay. All right, so we're going to take that out. We don't need that. All right, because there's the x component, 1 minus a -1, and then now for the y component, we take y2, which is the 1 here, and we subtract y1, so we've got 1 minus 4 for that component. And so when we actually work that out, my component form, 1 minus a -1, that becomes a positive there, so that is 2, and 1 minus 4 is -3. There's the component form. Pretty simple. Okay? All right. Now, to find the magnitude, what I'm going to do is just the distance formula. Now, I've already done x2 minus x1 and y2 minus y1, because that is the component form. So to find the magnitude, all I have to do is the square root, and I'm just going to do 2 squared plus -3 squared, which that's going to give me the square root of 4 plus 9, and that is the square root of 13. And there's my magnitude. Okay? All right, so one more example just to show you how this works. They may not give you a diagram. It may just actually tell you what the initial point and the terminal point is. So same thing here. Let's go component form. Okay, so we're going to take x2, which is here, minus x1. So I go -1 minus 4, comma, y2 minus y1, which is 5 minus a -7. And when I do that, I get -5. That becomes a positive 12. There's the component form. So now when I want to do the magnitude, all I have to do is take that component form, because I've already done the x2 minus x1 and y2 minus y1, and we just have to work this out. So what's that? 25 plus 144, which is the square root of 169, which is 13. So that one worked out kind of nice. Okay? So now you can do the front of the worksheet here. And the worksheet, the top part here, I didn't do examples like these. It just wants you to show that these two are equal, and you can do that one of two ways. You can either find the component form of each, or you can find the magnitude of each and just show that they're the same. And then for the rest of the sheet, you're just doing exactly what we did in the examples. Okay? Now, on the back of the sheet, it talks a little bit about vector addition and scalar multiplication, which is really pretty easy for the most part. I'm going to show you that in class tomorrow at the very beginning, and then we'll work through those a little bit, and then we're going to start talking about vectors in standard position and things like that tomorrow. So hopefully these notes here cleared up a little bit of what I was talking about today, and just make sure you've got that worksheet done when you come to class tomorrow, because I will check it for homework as a homework check. See you guys in class in the morning.